The atmosphere grows thinner, less denser, and lower in pressure as one moves upward on Earth's surface. It gradually gives away the vacuum of outer space, and there is no precise top of the atmosphere. Air becomes so thin at altitude between 100 and 120 kilometers up for that many purpose. The range of heights can be considered the boundary between the atmosphere and outer space. However, there are very thin but measurable traces of atmospheric gases hundreds of kilometers above Earth's surface. There are several different regions or layers in the atmosphere based on temperature, function, and composition. The first criteria is temperature, and that has 4 distinct layers: Troposphere, where we live, Stratosphere, Mesosphere, and Thermosphere. The Troposphere is the lowest layer of our atmosphere. Starting at the ground level, it extends upward to about 10 kilometers above sea level. We humans live in the troposphere, and nearly all weather occurs in this lowest layer. Most clouds appear here, mainly because 99% of the water vapor in the atmosphere is found in the troposphere. Air pressure drops and temperatures get colder as you climb higher in the troposphere. The next layer up is called the Stratosphere. The Stratosphere extends from the top of the troposphere to about 50 kilometers above the ground. The infamous ozone layer is found within the stratosphere. So ozone molecules, as you know, absorb high-energy ultraviolet lights from the sun, converting UV into heat. Unlike the troposphere, the stratosphere actually gets warmer the higher you go. That trend of rising temperature of altitude means that the air in the stratosphere lacks the turbulence and updrafts of the troposphere beneath. So commercial passenger jets fly in the lower stratospheres. Partly because it's less turbulent, layer provides a more smoother ride. Above the stratosphere is the mesosphere. It extends upward to a height of about 85 kilometers above our planet. Most meteors burn up in the mesosphere. Unlike the stratosphere, temperatures once again grow colder as you rise up through the mesosphere. The coldest temperatures in the Earth's atmosphere, about negative 90 degrees Celsius or negative 130 degrees Fahrenheit, are found near the top of this layer. The air in the mesospheres is far too thin to breathe. Air pressure at the bottom of the layer is well below 1% of the pressure at the sea level and continues dropping as you go higher. Absorb in the thermosphere, raising its temperature to hundreds or at times thousands of degrees. However, the air in this layer is so thin that it would feel freezing cold to us. In many ways, the thermosphere is more like outer space than a part of the atmosphere. Many satellites actually orbit Earth within the thermosphere. Variations in the amount of energy come from the sun exert a powerful influence in both the height of the top of this layer and the temperature within. Because of this top, the thermosphere can be found between 500 to 1000 kilometers above the ground. So temperature in this upper thermosphere can range from about 500 degrees Celsius to 2000 degrees Celsius. That's roughly 3632 degrees Fahrenheit or higher. The aurora, the northern lights and the southern lights occur in the thermosphere. Wow. Another criteria is function, and that the atmosphere has 2 layers, ionosphere and ozonosphere. The ionosphere is not a distinct layer like the others mentioned above. Instead, the ionosphere is a series of regions in parts of the Mesosphere and Thermosphere where high-energy radiation from the Sun has knocked electrons loose from their parent atoms and molecules. The electrically charged atoms and molecules that are formed in this way are called ions, giving the ionosphere its name and endowing this region with some special properties. Ozone, an unusual type of oxygen molecule that is relatively abundant in the stratosphere, as you know, heats this layer as it absorbs energy from incoming ultraviolet radiation from the Sun. Temperature rises as one moves up through the stratosphere. That's exactly the opposite of the behavior in the troposphere in which we live. As you know, the temperatures drop with increasing altitude.
I've got an idea.
The third criterion is composition. Then we have homosphere and heterosphere. The outer atmosphere begins about 50 kilometers from the Earth's surface and extends to the space. So gases are not evenly mixed but assorted by gravity, according to their atomic weight and reaction of the gases with solar radiation. So less than 0.001% of the mass of the Earth's atmosphere is in the heterosphere. The homosphere extends from Earth's surface to about 50 miles or 80 kilometers. Density of air changes with altitude, but the proportion of gases is nearly uniform. Of course, exceptions are ozone, water vapor, pollutants, and some trace chemicals. And talk about pollution, let's discuss air pollution. The introduction of contaminants into the natural environment can cause a diverse change and is called pollution, and can take the form of chemical substances or energy, such as noise, heat, or light. Pollutants, the component of pollution, can either foreign substances energy or naturally occurring contaminants. Pollution can be natural or human-made. So the natural causes like a volcanic activity. So volcanic eruptions emit a series of toxic gases, including sulfur and chlorine, as well as a particulate matter, ashes particles, but are used restrictly to localized areas. Winds and air currents can mobilize pollutants from the ground and transport them over large areas. Wildfires add carbon monoxide as well as a particulate matter to the atmosphere and could affect significant area, although in general they are restricted and may be contained. Microbial decaying process. Microorganisms which are present in any environment have a major role in natural decaying process of living organisms as well as environmental contaminants. This activity results in the natural release of gases, especially methane gas. Photochemical smog is a type of smog produced when ultraviolet light from the sun reacts with nitrogen oxides in the atmosphere. It's visible as the brown haze and is most prominent during the morning and afternoon, especially in densely populated warm cities. Cities that experience this smog daily include Los Angeles, Sydney, Mexico City, Beijing, and many more. This process, however, the source of it is quite apparent. The largest contributor is automobiles, while coal-fired power plants and some other power plants also produce the necessary pollutants to facilitate its production. Due to its abundance in areas of warm temperature, photochemical smog is most common in the summer. It forms in the morning when the tremendous number of people are driving their vehicles to work. Nitrogen oxides produced in the car engines are introduced into the atmosphere, which may combine with water to form nitric acid or react with sunlight to produce singular oxygen atoms, which then combine with molecule oxygen to produce ozone. Hotter days means more photochemical smog, especially in the densely populated areas such as Atlanta. So as more and more urban population arise around the globe, this problem is only expected to increase. But what is acid rain? Acid rain or acid deposition is a broad term that includes any form of precipitation, acidic components such as sulfuric or nitric acid that fall to the ground from the atmosphere in wet or dry forms. That include rain, snow, fog, hail, or even dust that is acidity. While a small portion of the CO2 and NOx that cause acid rain is from natural sources such as volcanoes, most of it comes from the burning fossil fuels. So, when we talk about natural factors that affect also air pollution, so the weather can be a significant impact on water quality, since different aspects of weather affects the amount of ozone and particulates that are present in a specific area. Sunshine, rain, higher temperatures, wind speed, air turbulence, and mixing depths all affect pollutant concentration. So sunshine can cause some pollutants to undergo chemical reactions, resulting in the development of smog. High temperature can speed up chemical reactions in the air. Rain typically results in less pollution since it washes away particulate matter and can also wash out pollutants that are dissolvable. Wind speed, air turbulence, and mixing depth all affect how pollutants disperse or spread out from an area. Temperature inversions have a great effect on air pollution. Whatever is a blanket of smog over a city or the melting of ice packs due to the ozone depletion, atmospheric temperature inversions are intricately involved. They influence the scope and intensity of the effects of air pollution on a temporary, localized basis as well as a long term. So surface inversions are responsible for producing smog, trapping the pollutants produced by vehicles, fires, and industrial activities.